The full potential of technology is often realised in times of crisis. Think the atom bomb or the power of flight, both of which came to the fore during wartime. Now, in the case of the COVID pandemic, it's the mRNA vaccine. Curiously enough, this modern medical miracle has been in development since the early 1980s, but it was only cleared for use in humans in December last year. So what does science have up its sleeve for us next? Well, one of the people at the forefront of this exploration is biochemist Jennifer Doudna. In 2020, she, alongside Emmanuel Charpentier, won the Nobel Prize in Chemistry for their pioneering work in CRISPR gene editing. Walter Isaacson has detailed the life and work of Jennifer Doudna in his new book, Codebreaker, and we caught up earlier.
I mainly picked this topic and Jennifer Doudna as a main character because I wanted to write about the coming revolution in life sciences. I realized that it was all about being able to treat molecules the way we treat microchips, to be able to reprogram them. And that requires understanding the folds and shapes of molecules, especially RNA. And so who is the person who really did the most to understand the structure of RNA? Well, it was Jennifer Doudna. And then when they figured out how to use RNA to make a gene editing tool, it was Jennifer Doudna and Emmanuel Charpentier who did it. And then when we had to face the ethics issues, Jennifer Doudna was the one at the forefront of the policy and ethics debate, and she helped turn the attention of scientists in the US to the coronavirus crisis. So she was a perfect central character. She wasn't always running to where the ball was. She liked to play a position on the football field and make sure she was doing something that other people weren't doing.
So at the moment, there's a massive problem around vaccine hesitancy. Do you think that understanding the science will help change attitudes?
We're afraid of things that we don't fully understand. We flinch when something's kind of mysterious. But in my book, I explain, I hope very carefully and understandably, exactly what RNA does. This was Jennifer Doudna's specialty, and how RNA acts as a messenger to take genetic code from the nucleus of our cell and build proteins. Well, if it does that, then you can instruct the RNA to build part of the spike protein of the coronavirus, for example. And that will make us so that we're immune to that coronavirus. And so once you understand that you're not getting the real virus and the real virus has nothing to do with it, and you're not going to have the real virus put into your DNA, I think people will be more comfortable with it. And that goes not just for vaccinations, but I think if people spent more time understanding what scientists do, marveling at the beauty of nature, then they would be more comfortable with science in our daily lives.
And in writing the story of Jennifer Doudna, you're also telling the story of all the building blocks that led to this moment.
Absolutely. Science builds on the shoulders of other scientists, as Newton said. And so in the 1860s or so, you had Darwin and Mendel figuring out things like heredity and the beak of the finch and Mendel's peas that showed eventually what we determined to be the gene. And then after we discovered the gene, it took most of the 20th century until we figured out that DNA was the carrier of the gene. And that's what James Watson, Francis Crick, and Rosalind Franklin did. And Jennifer, when she was a young girl, read about that and said, I want to stand on their shoulders. I want to take it forward. And so she and all of her colleagues take it forward and create these gene editing tools.